Welcome, everyone. Thank you for joining us on Parasoft's inaugural Ask Me Anything live session. I'm delighted to host this session with our guest speaker, Gareth. Today's topic is how to modernize embedded aerospace and defense software without risking compliance. Joining me is my special guest, Gareth. Gareth joins us as a founding principal of Noyes Consulting Limited, a boutique advisory firm focused on software for critical edge infrastructure, embedded systems, and distributed cloud technology. He has over 25 years of experience across the aerospace and defense industry, telecom, industrial, manufacturing, medical, and automotive sectors. Gareth has held executive roles at Wind River Systems, including serving as their chief strategy officer, where he led the strategy of mergers and acquisitions and their technology vision. He began his career designing embedded systems for particle physics experiments, which I have to think is a great over the beer conversation, and holds a PhD in high energy particle physics from the University of Birmingham in the UK. So, as you can imagine, Gareth has a fabulous accent. So, a
Thanks.
few housekeeping things. This is an Ask Me Anything, which I think of as an AMA. Um, and the instructions for the Ask Me Anything is as follows. Please submit your questions in the question box. Please be brief and to the point, as we want to be able to give Gareth a clear line of sight to the answer. My team and I will review and queue the questions selected for Gareth or myself, and we'll answer them live. And if we're not able to get to your question during the session, we will absolutely follow up with a written response post event. With further ado, I will jump into any questions that people might have. We've had a few that were queued, so let me end the slides and it'll just be me and Gareth.
Great.
All right. Um, so, my first question for you, Gareth, is since the need for safe, reliable software grows every day, what are some best practices I can use to help me keep pace with development and future proof my software investments?
Hmm. That's a great question, Joe, because we are seeing a lot more very reliable autonomous systems being developed across lots of different industries, and I hope that we can dive into what they are as we discuss this. The future is always very hard to predict. But being lazy, I'd like to look at what's already been done, and I think there are roadmaps from other sectors and industries that are going to help us manage the evolution of software, both for reliable and critical edge systems. A few things do continue to be true, and I think we know that these are going to continue to happen. One is the amount of software is growing
Hmm.
continuously. The complexity of software is continuously growing. The sort of applications that are being deployed are becoming more and more sophisticated. The speed of deployment is accelerating. The time
Right.
to market is reducing drastically. And then, I think when I look back on my career, a lot of our customers would think of building a specific embedded system, generation, X, and then, they go through design cycle and then deploy that and then build the next generation Y. Well, I think the world is changing and we have to adapt to software really having its own life cycle where we're moving from build once and deploy forever to continuous updates. And we see that in automotive as a great example where we used to buy a vehicle that was a software model 2020, and you might have had some fixes and recalls, but by and large, what you bought was what you get. Now, of course, with modern vehicles that are connected,
Hmm.
connectivity is a big theme. The need for continuous updates and improvements as the life cycle of the vehicle evolves is kind of the norm. So, how do we address that landscape? I like to think of, two aspects of the software lifecycle. One is the deployment. And I think, that's the sexy bit. Think about the
Right.
robot on the factory floor, the self-driving car, that's the fun bit from my perspective to develop. And what we're seeing there to address, the complexity, the speed of deployment, the amount of software is really decoupling your software from the hardware. So introducing a layer of abstraction so that you're removing hardware dependencies. So, technologies like virtualization and embedded systems, they have virtualization technologies called hypervisors that still maintain your real-time capability and can be functionally certified as well. So abstraction is key because it kind of decouples your software and allows you to evolve your software without worrying about what the hardware is doing or whether your hardware is obsolete. Reuse is really important. So, not thinking about building everything from scratch, but, building on the shoulder of what's happened in the past or our peers. So we can't reinvent the wheel and do a greenfield design every single time. So the notion of reuse is really very important. And it's actually a notion that is critical to functional safety. The notion of proven in use or, having some pre-qualified tools or libraries that are being used where you don't have to spend a lot of time re-qualifying those elements. You just they've been proven to work. They've been proven to be functionally safe. So whether it's standard C libraries or frameworks such as in Avionics, Aerospace 653 that are much richer environments that define how things communicate. So abstraction and reuse. And then at the deployment stage, I think componentization. I'm going to be referring several times in our discussion, Joe, to what's happened in cloud computing. And I think the thing that revolutionized cloud computing is the ability to componentize a piece of software, a small chunk of utility, whether it's microservices or just a container, that you can update at a very, very small bit of time. So you can focus on the requirements for a small bit of software. You can also throw it away and replace it with a new piece without affecting the overall system. And of course, that requires well-defined APIs. So architecting your system so that all the pieces can talk to each other. And embedded systems, things like POSIX were a good start, but we're evolving to much more complex architectures. And in the aerospace and defense sector, there's a push for an architecture known as MOSA, which is a componentized architecture. So that's the deployment: abstraction, reuse, deployment, and well-defined APIs. Now, on the development side, this is where I'd look to cloud best practices. So moving away from an edit, compile, debug at a developer's desktop and really thinking about the industrialization of software development. It's not just leveraging the compute power that the cloud provides, but also the high degree of automation that those cloud environments enable. So embracing DevSecOps and maximizing the automation of your build, your test, so that you're not having to manually, do your code coverage and your go over your test results, but that is all automated as part of your development pipeline. And then I think the final thing I'd say is, it's really important that you take the system view. So you might be working on a control unit on say an ECU in a vehicle, but remember that that's part of a larger system and also more often than not likely connected to some backend cloud infrastructure. So, you need to think beyond your embedded lens and think about the entire system, functional software, APIs, sort of web type applications interacting with embedded systems. So, we're seeing all of these approaches I've mentioned actually being endorsed and enforced by the Department of Defense in the US. So they're mandating, software modernization approaches, whether it's for the acquisition of software to get them faster, or to operate in software factories. So there's that high degree of automation. So, the roadmap that I've given you isn't, something that I've just plucked out of thin air. It's something that we're seeing in the defense sector and across all these other sectors. So
Absolutely.
That's
So that was a really complete answer, and you hit on some of the highlights that I thought would be an interesting way to future-proof software investments. But one topic we didn't touch on that I wanted to just ask you a follow-up on is what about Google Test? You and I've sort of kicked around this Google Test concept. Is open source an approach to future-proofing your software investments?
It absolutely is. I mean, I think that it kind of fits under industry best practice. I think whenever there are tooling approaches or frameworks like Google Test that a large developer community is familiar with, I think that allows you to stand on the shoulders of giants because you're not responsible for developing your own proprietary
Hmm.
infrastructure. There's a familiarity with tooling, and so we see open source and the adoption of frameworks that may have once been proprietary but now open source being reused over and over again. And I think what that allows us to do is to say, look, this is a consistent industry-driven approach to how we might do testing.
Hmm.
Um,
Hmm.
these are the tools, these are the workflows that people are familiar with, and then the overhead of learning the new system goes way down. And so we
Right.
can imagine that a developer who may have started in the automotive industry using Google Test could easily switch to another sector. So there's a benefit to a developer in terms of their career mobility.
Hmm.
Um, and so Google Test is a great example of a tool environment that is being reused. And then, I mentioned things like containerization, whether it's Kubernetes or
Right.
Docker or things like that. So they're kind of the de facto standards, if you like. I'm using air quotes here, but there is a standardization of these very, very rich and functionally rich tools and runtimes. And it makes a lot of sense to reuse them because of familiarity and proven in use.
Right. It seems to address that increased reliability, as you had mentioned, proven in use, right? Similar
Yeah,
to how the industry reuses hardware designs because it was proven in use. This is a similar approach to software, so it's a
yeah.
safer way. So,
It is similar. I mean, one of the caveats I don't want to put a fly in your ointment, Joe, but one of the difficulties when it comes to reliable and especially functionally safe regulated systems
mhm,
is I think the old way of thinking of functional safety was you want a very, very stable code base. You want minimal changes. You want things as they were 10, 20 years ago, and you don't
right.
want to change anything. Well,
Right.
that's not the reality of sort of the modern software environment. So the need to adapt your software, and I think that's where automation plays a big key. Is yes, things change, but if you have tools that allow you to understand dependencies of what's changed, for instance, if I change a piece of code, what tests do I have to update? What tests do I have to rerun? What things haven't changed, and what can I assume is is untouched by any modification I might make. So this notion of a very static development environment, just something that's very dynamic,
Mhm.
is kind of where we're going. And I think the only way to do that is to embrace sort of modern automation technologies and go with the flow.
Yeah, that makes sense. Well, I have a question that is potentially outside your wheelhouse, but I thought we'd still ask it. This live question came in, which is Gareth, what do you think about using multi-core processors in the A&D sector?
Okay, that's a great question. In fact, that takes me way back earlier in my career, just after I'd stopped being a developer at Wind River, I actually was responsible for driving the multi-core strategy there. And I think the harsh, so I think I would hazard a guess that the person asking this question may be in avionics or some other field because the world 20 years ago was you had a monolithic processor and you could think of a very sequential flow of code,
Hmm.
and life was simple. You knew there's only one line of code executing any one time, and you could think of the flow statements, and that was nice. Well, of course, the way that silicon manufacturers solve the power performance envelope is to do lots of things in parallel,
Right,
and that changes that fundamental serial view to one where things happen in parallel. There's
right.
no longer sequential. Um, but that's where rich environments, operating systems, Linux, things like that. They operate in a multi-processor environment. Of course, race conditions, determinism become very much harder. But companies like I have a bias. I was at Wind River for a long time. We spent a lot of time and effort retooling the base infrastructure, the real-time operating system, the hypervisors, to adapt to that multi-core capability. And that flows all the way through to the tooling. How do you test these systems that are now non-sequential and parallel?
Mm-hmm.
And again, automation, standard interfaces, standard protocols. ARINC is a great example of a system that allows for multiple operating systems, multiple applications to run in parallel. And the APIs of how they communicate, how many time cycles they have, it's very well defined. So a great example of reuse of a standard API with something like ARINC. So I think it's a step process to go through that single core to multi-core. But I think the industry has evolved, and I think we're coping very well with building those environments.
So it sounds like your suggestion is to embrace that advancement and rely on your open source, or rather rely on your OS and the frameworks that we have to manage that enhanced processor capabilities. So
Exactly. But as an embedded developer, you have to understand that your system operates that way.
mm-hmm.
So you have to learn kind of new tricks and techniques. I mean, if you're
Right.
going to meet deadlines and guarantee determinism, but there are solutions in the market and tools that can help you with that.
Right. Once again, falling back to your original paradigm of using standard tooling so that you're future proofing your investments. So that makes sense.
Exactly. Yeah.
All
And
right.
it's important to remember, Joe, that sort of enterprise IT systems, cloud systems are inherently very, very powerful. They don't just operate at the
Right.
multi-core chip level; they're at the multi-cloud. You might be running software across multiple data centers, and so that abstraction, the componentization I talked about, how they communicate between them, the level of robustness and redundancy. These are all problems that are being solved today. So it's not a net new thing.
Right. That makes sense. Um, well, the questions are really coming in quick, Gareth. So my next question is really around new automated and autonomous use cases in different market sectors. What would you tell a new entrant to the market, especially ones who don't have a history in developing in mission critical systems?
Mm.
Like, what would your recommendation be?
Right, that's a great question. I think what I've seen is there's a huge amount of innovation from developers who are not historically familiar with functional safety, as an example. But think of as sort of a new drone application. You probably start in with something that's really consumer grade technology that you're trying to retrofit to potentially deliver in packages. In the drone example, well,
Mm-hmm.
as soon as you start you know carrying 50-pound packages in the air, then you can bet that something is going to be regulated. So,
Right.
I'd say you've got to balance innovation with, do as much you can with the simplest and consumer grade technology that you can, but be aware of, the environment in which you're going to operate those systems. So, become familiar with, the safety requirements, the security requirements. There are lots of applications that today are either not regulated or self-regulated.
Mm-hmm.
Autonomous driving is a great example. We have on the streets of San Francisco and here in the Bay Area, we have Waymo vehicles that are self-driving and have been for a while. And that to a large degree they're self-regulated. They do employ methodologies that are sort of kind of best practices in automotive. That's called ISO 26262.
Mm-hmm.
There's similar environments in avionics. And this is where your tooling partners like Parasoft are experts in allowing you to maintain compliance to those standards. So understand what standards are applicable, automate as much as you can, rely on third parties to do the grunt work. Don't reinvent a whole process yourself. There's
Right.
whole ecosystems who are familiar with that. And then the final thing I'd say is it's easier to enforce as you go. So if you have a process that you set up that ensures robustness of your system, it's going to be much easier to be compliant than to try and retrofit an entire system as a one step before deployment. So,
Right.
enforcement as you go, understand the regulation environment, use partners, reuse as much as you can, um, and so that proven in use is a great example. We are working with a customer who is looking at creating autonomous aircraft. So think of Waymo, but for aircraft.
Right. Right.
And their approach is to retrofit an existing airframe because they don't have to recertify that base airframe infrastructure. They just
Yep.
certifying the control system around it. So that's a proven and use example of a real world application.
Yeah, and that tees us up for our next webinar, which is with one of these innovation startups that is using Cessna and broadening the airways through autonomous airplanes. So, if you're interested in that topic,
Yeah,
Gareth will be hosting one of our customers to do that in probably 6 or 7 weeks.
great.
But what I heard you say really was partnering with proven automators, such as Parasoft, is a great way to address that first question around how to adopt new automated and autonomous use cases inside of avionics. So I
Absolutely.
have another question that sort of shifts the conversation more towards path of least resistance. So the question is coming from one of our viewers: legacy embedded systems which are not cybersecurity compliant. What is the path of least resistance to update them with AI support? The question comes. This particular person's question stems from hardware challenges and the changes reopening certifications and compliance cycles, costing them more time and money, thereby negating the advantages coming with the upgraded systems of having AI built into it. So, I guess to summarize and give Gareth a few moments to formulate his thoughts, we're looking. The gist of this is as I adopt AI against old systems, it requires recertification and compliance of those systems. What's your recommendation to this person for getting AI into the systems to accelerate that code growth, as you had mentioned at the beginning, while recognizing that the compliance requirements are needing to be refreshed?
Yeah. So I think there are a couple of ways to view the intent of that question. That question actually, I think one is, how can you use AI to modernize systems? And I'll address that in just a second. I think the other is, recognition that systems that are deployed today may not be up to snuff with modern cybersecurity standards, and a retrofit is indeed a very costly approach. And I think that's where there's a trade-off between upgrading an individual component or doing a tweak to an entire system. So, in some cases, air gapping components that are known not to be cyber compliant. Now, an air gap doesn't ensure cyber resilience. We know
Right.
from Stuxnet and other thing that's not sure, but having a system view of security, and then again using automation tools. I think static analysis is a great example of very low overhead tooling in your development environment that can find cyber risks. So whether it's your OWASP top 10 or finding memory overflows and things like that, there are again tooling can help you with that. Now, when it comes to how AI can help in developing these mission critical systems, and I think in two modes. One is deploying AI inference engines at the edge, so having some inference that's running on an embedded system and is using AI, and object recognition, pathfinding in autonomous vehicles is a great example of that. And I think that's probably the hardest area to ensure both cyber and functional safety, because these systems are the exact way that they work is a little opaque in many cases. The
Mm-hmm.
traceability of input to output can be opaque. But we do see AI already deployed in some of the autonomous systems, and we often see that system level approach where, let's take autonomous driving again, because it's such a relatable example. Instead of having a single input, which is just a vision system with cameras,
Right.
having multiple inputs, whether it's LiDAR, radar, other things, and then doing sensor fusion, which is like a sanity check on your input. Am I seeing something with one system, not with another? So, there's the use of safety monitors, where you have a system that's doing a constant checksum. Is this system seeing the same as the other? Now, for embedded systems, I think development is where AI is absolutely ripe to use, because a lot of the complexity in the system, and this coming back to cyber, the development side of embedded systems is where we can absolutely leverage AI to get the best insights into not only development of secure code, but testing of secure code. Can I do extended pen testing? Can I validate that my system is performing exactly as intended? Am I meeting my security compliance requirements? There's a whole bunch of tooling that can help automate a lot of those processes. So, things that are often manual are great areas of acceleration for AI. So, documentation, traceability of requirements through testing and security use cases, build-in test cases, very complex, whether it's a component level or system level test cases. I view development as really the hotspot for AI and embedded systems, and deployment really being kind of the leading edge of where we're going to want to go, but a lot of uncertainty from a regulation perspective around that right now.
Right. So perhaps to summarize, there's really no path of least resistance, but rather your recommendation is precise use of AI. Um, you know, Potentially, what my team talks about is surgical applications of AI where it's most beneficial, potentially weighing the cost benefit, right? Introducing new tooling introduces new compliance requirements and certification requirements, but the benefits far outweigh that investment that this particular customer was sort of facing, right? So
exactly, absolutely. And I think, the thing about AI is that it can make a vast amount of data much simpler. So
yes.
think about, from a DoD security perspective, a STIG, which is really ensuring that the configuration of a software system is going to be secure. And then, you need to go through that process in order to get an authority to operate and deploy a system. Configuration you can have a inherently safe system that is misconfigured and then becomes unsafe. And so, configuration is very important. Agentic AI systems understand both the standards. They understand, your code. To some degree, they understand your overall architecture, and they can do the mapping of, what the standard expects you to do, and show you in your code where you have weak spots and give you remediation actions. And so, there's a lot of advancement on that agentic side that is doing that simplification of vast amounts of data. And that's where, CISOs and others suffer today, is understanding how do I break down the system into little chunks that I can take action on. And AI is incredibly good at helping you there.
Yep. That's really good advice. Our next question is gear shifting, right? Rather than talking about cybersecurity or SecOps, this one talks about and capitalizes on your experience having been in the space a long time, which is how do you make the sector of A&D really exciting and entice people to come? So this question, in the words of the asker, is with the increased business and defense sector in Europe, we're experiencing staffing issues. Most younger engineers prefer big name companies like Google, Meta, Apple, etc. for a variety of reasons, the food being paramount. I can tell you the cafeteria at Google is amazing, seeing as I live right there next to them. Going back to the question, the transfer of existing know-how, particularly at systems level, is becoming an issue as people retire. How can this sector entice more people to join? So, tapping into your leadership role, how did you manage this at Wind River? Right, enticing talent to come and join you in an area that might not be as sexy or have as many fancy snacks.
Yeah, no, I think this is a great question. If I look back, I spent almost 25 years at Wind River, and there were times when I asked myself, was I wasting my career, when I had friends at Google and other places. But I think the great thing about the A&D sector is you build real things that have real life impact. Whether it's a satellite constellation, some incredible hypersonic missile, or some aircraft that does amazing, sort of physics-defying aerodynamics. I think getting back to connecting the dots between, a developer's purpose and showing that they can drive an outcome in their work environment, and I think that's what the aerospace and defense sector has going for it. Now, I think the sector has also recognized that being antiquated in its development processes, its software acquisition processes, things like that, was kind of a barrier to attracting sort of these cloud native people. And so the DoD's software modernization white paper, and I think Eric Schmidt was on a committee that actually was a catalyst for doing that. And so telling the defense sector, look, the way that you've been doing things is both antiquated, which is a risk because you're very, very slow at deploying new systems, so you have to change your approach. And they've embraced cloud technology, all the things we've just been talking about. But that makes the defense sector a much more attractive proposition for those Silicon Valley types, from Google and Meta and others, that now have the skills they can transfer into that sector. So I'd say, align the excitement of the project to the passion of a developer, and show, connect the dots for your developer. You're working on this, and this is what you're building. There's nothing like it. I was lucky enough to go around and visit customers who are building, aircraft, satellite systems, industrial robots. There's nothing like being on the shop floor, seeing something work. So I think promoting that, and then leveraging, we talked about Google Test, Joe. So embracing modern tooling is a great way to attract developers. You're not going to attract young developers by saying, I want you to come and update some COBOL code from some back system. You want to say, look, I need you to apply your know-how of sort of continuous deployment to make our F-35 jet fighter sort of super capable. I want you to upgrade things and work in a fast manner. So, I think the young blood, young talent has the skills that A&D need. A&D has the exciting projects that developers need to work on. I think there has to be a cross promotion of those two sides of the coin.
Absolutely. So I agree with you 100%, with all of these exciting places to work. I think it's really important for us to connect the outcomes that you'll be impacting with the skills that you'll be learning and developing. And Google Test is one of them. An API first approach is another one of them, which you mentioned at the beginning. Containerization and scaling into the cloud infrastructure are all skills that any good developer would want to cut their teeth on or become experts at, and they are applicable in the A&D space. And so by highlighting how using these tools to do something really impactful, whether it's building a safer jet or managing a broader range of satellite systems, I think it's that delicate balance of skills building and interesting projects. So we've already gone over, and I've been given my warning, so I'm getting the hook. So with one closing question for Gareth, you are a leader who's worked across multiple mission critical systems in many different industries and sectors. Can you share with us a little bit of prognosticating? How do the changes in these sectors compare to what you're seeing in the market today? And then what's your advice on how to absorb these changes?
So I was very fortunate to work across multiple sectors, and the pattern recognition was this fundamental shift from a monolithic sort of hardware-centric embedded design to something that's very scalable, adaptable, componentized, built with DevSecOps. That's the software-defined aspect, whether it's software-defined telecom infrastructure, software-defined vehicles and automotive, software-defined automation and robotics. We're seeing that the same shift happen across every single industry. So every industry is responding to trying to increase the value of the infrastructure deployed in edge systems through the value of software. So software has become front and center to the capability of these systems. And I'd say that is common across all sectors. Now, they have nuances of how they take care of that, what standards they use, and things like that. So there is a translation between one another. But if I take a high-level view, it's really the same common story that I outlined earlier. Now, in terms of the interest in, I think the telecom industry was actually, in my view, the first sector to go full software-defined. So 5G infrastructure now is fully software-defined. 5G network runs on a standard Intel server. It's all Kubernetes containers deployed at massive scale, updated continuously for incredible reliability and really superior network connection that we take for granted. So telecoms has embraced it. I think the second area where they were coming from behind, but the automotive market, which was a bit of a laggard in terms of some of these technologies, has fully embraced software-defined vehicles, and they've had to through electrification, and the whole industry is going through a transition. But the software factory approach being fully embraced in automotive. Aerospace and defense, I think, is signaling very strong intent. It's been slow in practice to deploy all these software-defined infrastructure, but this movement that is starting to happen. And when I talk to large system integrators, the Honeywells, Raytheons, and others, they all have digital transformation strategies that require them to embrace all the technologies I've talked about. And I think that the laggards right now, honestly, is probably the industrial sector overall. And there are probably financial reasons, like if it ain't broke, don't touch it. So oil and gas, but they've been through effort to think about modernizing software development, to embracing virtualization, things like that. But it's going to take much longer to transform those sectors because they just don't have the financial catalyst to want to change.
Yeah.
So very similar story. We've talked a lot today about aerospace and defense. If there are developers on this talk that are thinking of adjacent industries, I think your embedded skills are easily transferable to automotive, to telco, to industrial systems. So that's the great news for you if you're embracing sort of modern methodologies and approaches.
Yeah. And if you're looking for ways to expand your skill set, it sounds like from Gareth, you can learn a lot from these leading edge innovators in software defined telco, software defined cars, software defined planes. So with that, on that very upbeat note, love to, if you're interested in learning more about what Parasoft has to offer, I'm going to throw up a slide here that gives you a chance to look at some of the other content that we have that might be of interest to you. Just take a quick look at that QR code and jump over there and check out our mostly ungated content. And if your question didn't get answered, or if you were shy about asking the question, we would love to chat with you. So feel free to take a quick look at that QR code and reach out to us. Thank you so much for joining us today. Thank you, Gareth, for your incredible insights and commentary. And with that, we'll be signing off. Bye, everybody.
Great. Thanks for your time, Joe. Bye.